Hello everyone, hope all is well today. My name is Gilles. Today we'll learn to perform a one sample t-test with R. First thing I'm going to do is open an R editor window. So I'll go to open script. This will be a file that I saved in the past, or it's an open document with a Mac. I'm going to go into documents because this is where I saved my file. And the name of the file is actually flamepropagation.r. And then here we will see actually some commands that we saved in the past to use in the future. And so if we read my comments, this will describe what I want to do. So the first comment says that we want to verify that the mean is 10. To do so, we're going to first create a numerical variable in R. The name of the variable will be x. We'll use the C function to combine some values together. And to create here, it's going to be a very small data set. And so I select my commands, Control R or Command Enter to submit to the console. So if I go to the console, we see that the command has been submitted. And then since my data set is not very large, I'm going to verify normality before doing a t-test with a QQ plot. And so if I use a function QQNorm of my numerical variable, and AB line, this will add a line to the QQ plot where the intercept is the mean and the slope is the standard deviation. So if I select these two commands and submit them, and so I see that I created a QQ plot, and we see a linear tendency in a QQ plot, so it is reasonable to assume that the variable is normally distributed. Our variable here is actually the velocity of flame propagation of children's clothes when exposed to a flame. From prior studies, it was claimed that the mean is actually 10 seconds for a particular fabric, and so we're going to verify this with our little experiment. And so we want to use the t-test function, so t.test will submit our numerical variable inside of the function as the first argument. Our null hypothesis will be that the mean is equal to 10, and by default R is going to use a two-sided alternative. Okay, and so as I submit this command, and then we go to the R console and see our output. And so here R tells us that it's a one sample t-test. The variable is x. It gives us the value of the t-test statistic, degrees of freedom for a t-test, and the corresponding p-value. Here the p-value is actually very large, it's around 80%, and so the evidence against the null hypothesis in favor of the alternatives is not significant. So we should not conclude that the mean is different than 10. R also describes the alternative hypothesis. It tells us that the true mean is not equal to 10, so we do verify that it's actually a two-sided alternative. And on top of that, R also gives us a confidence interval at a level of confidence of 95%. So we're 95% confident that the mean velocity is somewhere between 9.95 seconds and 10.03 or 0.4 seconds. Okay. We can also change the level of confidence if we want, and so if we did not want a 95% confidence level, we could add an argument. Here I'm going to take out the mean, and I'll just actually want to get to the confidence level, or confidence interval. So I'll put conf.level at 98%, so 0.98, let's say, and then I'll use a $ with conf int. And so our t-test at a confidence level of 98%, asking only for the confidence interval, we get the confidence interval and the level of confidence. So we are 98% confident that the mean velocity is somewhere between 9.9 seconds and 10.05 seconds. Okay, so if we did not add the confidence level, by default we get a 95% confidence interval. So this is a two-sided t-test. I also want to show you how to change the alternative to either be a right-sided alternative or a left-sided alternative. And so what I'm going to do now is create a data set. I'll call it data. So this will be a data frame where we read some data from a file. So we'll use the function read.table file.choose will be the first argument to force R to ask us where is the data. And then header equal to true, because my first row in my file will contain the names of the variables. And then sep equal to, and then in quotation marks, I'll put a /t to indicate that we'll have, whoops, /t tabs to delimit the columns. And so my data frame will be called data. And so I have a file in documents. The name of the file is concentration. So if I try to find concentration, text. And so these are actually some concentrations of a particular substance in parts per million. If I use the function names of my data frame, I will display the names of the columns. So here we actually just see one name, so we have one column, which is a concentration. And let's say that we want to test the null hypothesis that the mean concentration is less than 65 parts per million. Okay, and so we'll put in my function t.test the name of my data frame is called data, $, and then I put the name of the variable. So here it's concentration. And so we want to test that the mean concentration in the null hypothesis is going to be 65. And then our alternative, which is our research hypothesis, is that the mean is going to be less than 65. So I'll put alternative and then equal to, and then in quotation marks, less. And so we'll get a left-sided alternative. And so here in the output, R describes that the alternative is that the true mean is less than 65. We get our t-test statistic. Degrees of freedom is 59. So here we see that we have a large data set. And the p-value is very small. It's in the order of 1 in 1,000. Okay. And so we have strong evidence that the mean is actually less than 65. We have a one-sided confidence interval, so we're 95% confident that the mean is actually less than 62.5, so we're confident that it's less than 65, and it also gives the value of the mean. Okay. Now, let's say that we wanted to test that the mean was greater than 65 in the alternative. Instead of using the argument that the alternative is less, we'll use the alternative is greater. And then R describes the alternative hypothesis. It says that the true mean is greater than 65. And so for this alternative, here we see that the p-value is actually extremely large. And so the evidence against the null hypothesis in favor of a right-sided alternative is not significant. And if we see the corresponding one-sided confidence interval, so we're 95% confident that the mean is greater than 57, but this is not greater than 65, so we're not 95% confident that the mean is greater than 65. Okay, so our evidence against the null hypothesis is not significant. All right, so this is the t-test. Have a good night.